The measures of three of the interior angles of a quadrilateral are 60 degrees, 110 degrees, 90 degrees, and 90 degrees. What is the measure of the fourth angle of this quadrilateral? Well, let's just talk about this for a moment and see what's happening here. A quadrilateral, of course, it's called a polygon. And that means it's a shape with straight sides that's closed. So we can draw any four lines. 1, 2, 3, and 4. And we formed a polygon that's called a quadrilateral. It's called a quadrilateral again because it has four sides. And the word quad right in it represents 4. So it's a four-sided polygon. And here's our example. Now when they give us the interior angles, right, they tell us that one of them is 60 degrees, one of them is 110, and one of them is 90. We're trying to find the fourth and mystery angle. Now I'm going to redraw the shape to represent the situation over here, right, to get a better sense of what's happening. Let's start with a 90-degree angle. Well, 90-degree angle always looks like some type of L, so that's my approximation right there. It's a right angle, shown that way. A 110-degree angle would be a very large angle, of course. Of course, much larger than 90. So here's a 90-degree angle again, but we're going above that, maybe like this. Right? This is going to be a little bit larger. It's 110. And then we have a 60-degree angle. You know, here again, you can think of a reference. This would be 90 degrees this way, another L shape. But 60 degrees is less than that, right? Oops. So instead of having another right angle, we come down maybe a little bit like this. And eventually it'll meet this line right here. We just extend it up. So this is our 60-degree angle. I could have redraw that a little bit better. Because again, the right angle is going up here, so 60 degrees maybe a little more extreme. Like that. A little bit better. Okay. So our goal is to find this mystery angle. How do we do it? Well, one key realization is to either realize or somehow remember that a quadrilateral and every four-sided polygon has exactly 360 degrees. That's the key. And the principle behind it, if you want to remember it, if you're like me and you don't want to just memorize stuff here, you can think that, oh, well, I know about a triangle. Right? And a triangle here, we can cut the shape in two triangles. Here's one. Every triangle is made from 180 degrees. And since a quadrilateral can be constructed or built with any two triangles, that means that it has to have 360 degrees, right? Because each triangle in the quadrilateral has 180 degrees, so altogether this quadrilateral will have 180 and then another 180 degrees. And we can keep going with this principle. If I had a five-sided shape, 1, 2, 3, 4, 5, this could fit three triangles, 1, 2, 3, there's my rough sketch, and that means it has to have 540 degrees, because if we add each piece, they're each 180, those triangles that fit in there. Add them up all together, we get a total of 540 degrees. And so any sided shape they give you, if you can find the number of triangles that can build that shape, then you can count the number of angles that must be inside. And here that's very useful to us, because we know we have 60 degrees already, right? And 110, and 90. So we want to ask, well, what's the missing angle that'll add us all the way up to 360 degrees? Well, first I want to add what's easy to me. I'm going to add 90 and 110. I know that's 200, you can check that. And then 60 and 200, right? Well, that's just 260. So 260 plus something would give you 360. You can almost see it, that there the answer must be 100 degrees, right? This angle has to be 100. And if we can't see it, what you could do if you're trying to find 260 plus something that gives you 360, use the reverse or inverse operation. To find what I have to add to 260 to get 360, I could subtract, or I can go backwards, 360 minus 260, and that'll give me the answer. This is based on a simple principle of inverse operations, and you might have heard of this before, but if not, let's just quickly go over it. What inverse operations focus on is the really useful property that, for example, if I take 3 and I add something to it, like 4, well then I get 7, right? Well, the inverse operation says that, hey, look at that. 7 minus 4 then gives you 3. And 7 minus 3 gives you 4. Addition and subtraction are inverse operations. They go back and forth. And so is multiplication and division. For example, 3 times 4 gives you 12. But then it's kind of cool because 12 divided by 3 gives you 4. And the reverse, 12 divided by 4 gives you 3. Right? The multiplication and division are inverse operations. So that's going to really come into play, especially as you explore algebra. Anyway, I hope this helped. Quadrilateral review. Thanks.